Hi student. So today's session is on moving coil galvanometer. So I will solve a problem which came in JEE Advanced 2018. Okay. So this one came in 2018 JEE Advanced, right? So this was on moving coil galvanometer. Now let me go through the question scheme. The question was, a moving coil galvanometer has 50 turns and each turn has an area 2 into 10 to the power minus 4. Okay. The magnetic field produced by the magnet inside galvanometer is 0.02 Tesla. The torsional constant of the suspension wire is 10 to the power minus 4 Newton meter per radian. Okay. Now I will explain you what is torsional constant. Next, when the current flows through the galvanometer, a full scale deflection is occurs if the coil rotated by 0.2 radian. Okay. The resistance of the coil of the galvanometer is 50 ohm. This galvanometer is to be converted into an ammeter, capable of measuring the current in the range 0 ampere to 1 ampere. For this purpose, a shunt resistance is to be added in parallel to the galvanometer. Find the value of the shunt resistance. So, we have to understand the problem. So, what is the statement? The statement is that there is a galvanometer. In this galvanometer, a current is passing, right? And there is a deflection happen. And now the question is that most of the parameters are given. The galvanometer is to be converted in a ammeter. So now question is, what is ammeter? A relation between galvanometer and ammeter. So the question finishing part is that galvanometer is going to convert it in an ammeter, and the ammeter, which is having the capability of taking the reading from 0 ampere to 1 ampere. Okay, and for this purpose we need to add a shunt resistance with the galvanometer. What is the value of the shunt resistance? So first of all, let us understand what is ammeter. So if this is the galvanometer, let me say you G. This is a galvanometer, and with that there will be another resistance called S. S trace. This is shunt. Now the current is flowing. Main current I. It will be one is Ig, one is Is. Okay. So galvanometer, the main current will be divided into Ig and Is. So shunt is a resistance added with the galvanometer. Okay. Mind it, this shunt is a resistance added in parallel with the galvanometer. Okay, then only it's become an ammeter. So ammeter is an instrument which is measuring current. Okay, and inside the ammeter there is a galvanometer and a shunt resistance. Fine. Now the question here is that what is the value of this resistance S? We have to find this resistance. Okay, and before that in the problem they have given galvanometer related parameters. From there we will get the Ig, the current through the galvanometer, and this resistance also given. Rg is given 50 ohm for this galvanometer. So Ig will get from the the relations of the galvanometer, and from there we will get the resistance of the shunt. Fine. And the main current is I. So maximum current will be 1 ampere. This will be divided into Ig and Is. Okay. So this is this concept you have to understand. The main current will be divided into Ig and Is. So any max current will be, so shunt is the thing which will shape the circuit. If there is a high current, that will flow through the shunt, right? So this is the structure of an ammeter. Now we'll go to the galvanometer. Fine. So here is a small structure of galvanometer. If you see this one, let me take it closer. So what happened in galvanometer? If you see here, in galvanometer there is an already predefined magnet will be there. There will be a magnet. Inside the magnet, there will be a coil. Okay, and through this coil, the electric current will pass. So whenever there is a current will pass in the coil, so as you know that as you know that in a current carrying conductor, when it is getting passed in a present magnetic field, let's say there is a magnetic field present and the current is passing through this conductor I. So this conductor will feel a magnetic force, the magnetic force, that FB is equal to, LIB. L is the length, I is the current, B is the magnetic field. So this force faced by this conducting wire in presence of a magnetic field. The same technology we are applying here. We are having a magnetic field present. It is radial magnetic field. There is a cause for that. And also there is a coil of n number of turns. And inside the coil, whenever a current is passing, this coil will face an magnetic field, and it will give some deflection, highly sensitive. It's a high sensitive, means for very small, like small current of 0.1 ampere, so this coil will deflect. Now deflect means, so there is an phosphor bronze, so this is very sensitive instrument, small current, it's getting deflect due to the magnetic field present. Now this deflection, this deflection couple will be balanced by the restoring couple. Will balanced by the restoring couple inside the galvanometer, right? Now let's come to the equation. So the equation will be, the torque. Here the torque tau is, NIAB. So torque faced by this coil, right? So torque, N is the number of turn, I is the current passing through the galvanometer, A is the area, and B is the magnetic field, which is already present, the radial magnetic field. So this is the torque faced by the coil. Okay, because you know that net magnetic force on this coil will be 0, but this torque will be present over there. Now this torque getting balanced by restoring torque or restoring couple. So restoring couple means, so this particular conducting wire will trying to come back to the original position after deflection. So that's the restoring couple. So restoring couple having the C and theta. So C is the torsional constants, depend on the medium we are using, depend on the material, and theta is the angular deflection. Okay. Now the equation will be in equilibrium, the deflecting couple tau NIAB will be balanced by the restoring couple. Okay. So here theta, okay, theta and I here, as you can say that theta is equal to N A B by C into I, like that. Okay, so this deflection is depend on the current I. This deflection is depend on the current I, and this part will be constant. This part will be, so we are saying it like a K. So torsional constant. So theta, the deflection is directly proportional to the current I, and this part is the torsional constant. Okay, so this is the theoretical part of the moving coil galvanometer and its deflection. Fine. So this theta and this, now how we are making the galvanometer highly sensitive, we can increase the magnetic field, and we have some limitation of increasing area and N, and also this C, the torsional constant, we are taking the material which is having very low value of the torsional constants, okay, to get the higher sensitivity of the galvanometer. Okay, so this is the theoretical part. Now I will solve this one. Okay, now what parameter we are receiving from here? A moving coil galvanometer 50 turn, that means N is equal to 50. Each turn has an area, A is equal to 2 into 10 to the power minus 4 meter square. Okay. Now next is that the magnetic field produced by the magnet inside the galvanometer. That means this is the B. The B magnetic field is 0.2 Tesla. So Tesla is the unit of the magnetic field. Tesla. Okay. Now next is the torsional constant of the value is 10 to the minus 4. So here you can write that theta, it will be torsional constant, right? So it's showing 10 to the power minus 4. Now, when the current flows to the galvanometer, the full scale deflection occurs if the coil rotates 0.2 radian. Okay, so this is 0.2. That is the angular measurement, right? The rotation of the coil, the deflection theta. Now, the resistance of the coil, and also, so torsional constant is 10 to the power minus 4. So here torsional constant means, K is equal to 10 to the power minus 4. We will be receiving here for the, the torsional constant, right? Now, they have mentioned that the resistance of the coil of the galvanometer is 50 ohm. So, Rg is equal to 50 ohm. The resistance of the galvanometer, right? Fine. Next is that, what next parameter we are getting? The galvanometer converted in an ammeter. So this galvanometer we are going to convert in an ammeter, right? And the range of the ammeter is 0 to 1 ampere. So max current will be taking 1 ampere here. Max current will be 1 ampere, and from here, so let's write the equation NIAB is equal to C theta. NIAB is equal to C theta. So from here, this I is the IG, the current passing through the galvanometer, right? So here N is 50. I'm just writing the part. Then I we don't know, IG. A is this one, 2 into 10 to the power minus 4. Okay, 2 into 10 to the power minus 4. Fine. Next, B. B is 0.02 Tesla. B is 0.02 Tesla, right? So this will be equal to C theta, right? So K, we know that 10 to the power minus 4. So if we C theta I am taking here, so it will be 10 to the power minus 4 into theta is 0.2 into 10. Okay. So from here we are getting Ig. So Ig is the current which is passing through the galvanometer. So that will be 0.1 ampere. Okay, this is the Ig. Now I hope it is clear. So we have all these parameters, and from this relation we have received the Ig, the current through the galvanometer, and the main current is 1 ampere. This is the max range. We have to ensure. Now we will go inside the shunt. Okay. Now let's go inside the shunt here. Okay. So we got the value of Ig here, that is 0.1 ampere. Now inside the galvanometer, right? Inside this is the galvanometer, and there is an shunt we are adding. This is galvanometer, and this is Ig, the main current I, which will be max 1 ampere, and this will be the Is, and this is the S. Okay, so Is is I minus Ig, right? So what will be the equation here? So Ig into the Rg. Rg is the resistance of the galvanometer, is equal to I minus Ig into S. So here Ig is 0.1, Rg is 50, 1 minus 0.1 into S. 1 minus 0.1 into S. So we are getting the value of S will be, what will be the value of S? It will be 5, divided by 0.9, right? So that means S is equal to 5.55 ohm. So this will be the answer, right? So we got the answer. Okay, so this came in the JEE Advanced 2018. So take home message is so this is a straightforward problem you can solve, but you have to know the full background of the theoretical knowledge. So we learn what is galvanometer, what is the internal mechanism of galvanometer, and what is ammeter. An ammeter is built up by galvanometer, and inside the galvanometer there is a coil which is highly sensitive and deflecting whenever a current passing through it. It's a current detector, right? Okay, thanks for watching. Any doubts, please text me through my WhatsApp number. I'll definitely respond. Okay, thank you.